Hi guys, hi engineers, and welcome to the ride. In today's topic, we're going to answer sample problem for the power screw. We're already familiar on this topic sa ating machine design and sa mga nag-a-advance. Sakto dito ka. Welcome to the ride. Ayan, magsasagot tayo ng problem. And before that, of course, we're going to, refresh muna natin yung mga sarili natin for the formulas for the power screw. So sa power screw, we all know that the function of the power screw is to convert the angular motion into linear motion. Of course, this is a machine design topic. Hindi mawawala dyan yung mga torque, yung RPM, the power, the efficiency, and so on and so forth. So power screw has this scenario or has this setup. So we all know that this is the screw and this is the nut, and introducing the angle lambda, which is the lead angle. So of course, kapag meron siyang torque, meron din siyang force. So mamaya ano natin yung mga formulas for this. So I'm just introducing or para mas ma-refresh tayo so ano ba itsura ng mga power screw. So meron tayong first setup, and this second setup has the effect of the collar. So makikita din natin mamaya sa formula. So meron tong second setup na nut and meron tong collar, and this first setup has no collar. Okay? So ano ba yung mga formulas niya? So we have the angle. So we have the angle lambda, which is the lead angle. So ito yung mga ano niya, designation. So your lambda is your lead angle. Your L is the lead of the screw. Kapag sinabing double threaded, that is 2 times P, which is P stands for the pitch of the screw. And pag sinabing triple threaded, that was 3P. So just multiply your pitch of the screw with 2 or 3 if it tells that double or triple on the problem. So kapag single, that will become L is equivalent to pitch of the screw. So of course, we have introducing another angle. Bukod sa lead angle, we have the friction angle. So kapag involved si friction angle, so laging may coefficient of friction or the vice versa. Kapag involved si coefficient of friction, meron kang friction angle. So meron kang dalawang angle sa power screw. You have the lead angle and the friction angle. So those are the formulas for the angle formulas. And of course, meron tayong torque formulas. So we have a lot of torque formulas here. So no need to memorize. So siguro konti kailangan mo intindihin, pero some are needed by principles only. So ano bang una natin dyan? So we have this torque designated by letter T. TR is equal to WDM divided 2 tangent of beta plus lambda. So that was torque needed to raise the load. So we all know that W is the load, DM is the mean diameter. So wag malilito, we all know that we have the outside, the root diameter, and this mean diameter. So yung mean diameter is just the average of your root diameter and major diameter. So we all know that beta and lambda is the lead angle and the friction angle. So meron din tayong TC na tinatawag. So what is this torque? So it is the torque required to overcome the collar friction. Why? Kasi meron tayong pinakita kanina sa second setup na may collar. So sa first setup wala. So sa second setup may collar. So that's why I show the second setup kasi may collar yon. So of course, we have this total torque or the total torque input of the screw. So just combine the TR plus TC and we have our third torque here, which is the total torque of the screw or the total torque input. So meron tayong isa pa, T sub O, WDM divided 2 times tangent lambda. So that is the torque required to raise the load but neglecting the effect of thread friction. So kung meron kang TR na may tangent beta plus gamma, and this torque required to raise the load but neglecting the effect of the thread friction. So this is your thread friction. Just make this 0 and you have this TO. So no need to memorize the TO. Just make the TR, yung friction angle nun going mo lang 0, and then you have this TO. And lastly, we have this torque, and torque required to lower the load. So kung beta plus alpha yung TR mo, so just make it negative and you have this TL. Okay, we have the TO, the TL, the TR, the TC, and of course the total torque input. So sa efficiencies naman tayo. So meron tayong dalawang efficiencies. So ano yun? Ang una is your efficiency of screw alone, which is the ratio of the TO divided by the TR. So kung makita mo, para ma-derive mo to at hindi mo natandaan to, we all know that the TO is WDM divided 2 times tangent lambda only kasi nga siniro mo na yung tong beta dyan. So we all know that the TR is WDM divided 2 multiplied by the tangent of beta plus lambda. So just cancel this 2 and you have this tangent of lambda divided by tangent beta plus lambda. So no need to memorize. Just know the principles. Okay? And we have this second and last efficiency, which is the efficiency of screw and collar. So and it is just the ratio of TO divided by total torque. TO divided by TR plus TC. Kasi ito yung total torque. And as you can see, guys, TR dito, meron ka lang TR dito, at dagdagan mo lang TC na pwede mong masabi that EK is lower than the efficiency of screw alone. Why? Kasi TR lang yung nasa ilalim mo dito, tapos biglang madadagdagan ng TC dito, which is lalaki yung denominator mo, making your efficiency lower comparing to this. So, mamaya, tingnan natin kung tama. So, tara, sagot tayo ng problem. Pero bago yan, kuha tayo ng dilaw na itinta. So, ayan. I hope makatulong ito sa pagre-review ninyo a 32 mm diameter power screw with a pitch of 6 mm is used to lift a load of 57 kilonewton. So that was huge, no? So the screw is single-threaded and has a square thread form. The screw rotates at 45 RPM and supported by a collar having a mean diameter of 45 mm. Consider a coefficient of friction of 0.1 for both thread and collar. Determine the total power input and find also efficiencies. So, dalawang hinahanap, no, guys? Determine the total power input and find also the efficiencies. So, isa-isayin lang natin given. So, pag sinabing a 32 mm diameter engineer at walang sinasabing specific kung anong klaseng diameter siya, that will automatically your outside diameter or your major diameter DO, 32 mm. So, we have a pitch of 6 mm. It's used to lift a load of 57 kilonewton. Of course, that was the W. So, gawin na natin siyang Newton agad dito. So, 57, the 32 here, the 6 mm pitch. The screw is single-threaded. So, pay attention to those small details kasi it has a huge impact on the result of your solution. And the screw is single-threaded, meaning your L is equal also to pitch. Then, kapag sinabing double-threaded, that will 2P. Kapag triple-threaded, that will become 3P. But it is single-threaded, so that will be equivalent also to pitch. And has a square thread. So we all know, engineer, hindi ko lang nasama kanina sa pag-refresh o pag-refresh ng formulas. We all know, guys, or engineers, that kapag sinabing square thread, we all know that H is equal to 7/16 times the pitch. Kapag trapezoidal naman, H is equal to 1/2 P. So dito na nalagay, para hindi malito. Kapag buttress thread, 0.633P. Yeah. So we all know that kapag usapang formula ng power screws and kanina sa mga based on the refresh nating formulas, laging involved si mean diameter. And we all know that if we projected it based on the drawing, dm is equal to average of do plus root diameter, and it is also equal to the difference of major diameter and tooth thickness. And ano yung tooth thickness mo? Ito yan. Okay. So, kapag sabing tooth thickness, para siyang, kunyari, ito yung thread mo. So, ito yung H mo, yung lapad ng ngipin. Or the tooth height or tooth thickness. So, that was the H. So, mapaproject mo dyan, pag project ka dyan circle, it will involve the mean diameter, the outside diameter, the root diameter, and the tooth thickness. So in order for us to get the dm, so that will become do 32 minus 7/16 times 6 mm. So what's the amount of that? So guys, huwag niyong kakalimutan yung calculator niyo lagi. Ayan na yung buhay niyo. Siyempre, as future engineers and as engineer, of course. So we have the 29.375 millimeter. Okay, so meron tayong dm. Ano pa yung mga meron dito? The screw rotates at 45 RPM. It's supported by a collar having a mean diameter of 45 mm. So DC. So kinakalat ko na yung mga given. So maging alert lang kung nasan sila para mas mabilis kayo mag-solve. And consider a coefficient of friction of 0.1 for both thread and collar. So F is equal to FC is equal to 0.1. So it is not always the case, no? Sa case na to kasi parehong value yung coefficient of friction sa thread and collar, pero hindi lagi yan. Minsan mas mataas si thread, minsan mas mataas si collar. So dito lang siya equal. So natin determine the total power input. So we all know that the power input, it is also the same sa ibang problem ng machine design, that was the Tn divided by the constant. So the total torque multiplied by the end screw, and the end screw is your RPM divided by. So we all know that these constants, in order for your power to have a kilowatt unit, we need your torque to Newton mm, and this is in RPM, and it should be divided by the constant of 9.549 times 10 raised to 6. So kung gusto nyo ng derivation yan, meron ako sa acting page. So kung paano nakuha yan. Pero ayan, alam naman natin yan way back on our strength of materials days, our machine design days. So di pa pala tayong pwedeng mag-compute kasi we all know that ang meron lang tayo is the 45 RPM, but we don't have enough the total torque. So the total torque is as the formula of TR plus TC. So unahin muna natin si TR. Guys, we all know that TR is WDM divided 2 tangent beta plus lambda. So meron ba tayong beta? Wala pa. So beta is just the arctan of 0.1 or F. So ayan. Pasensya na sa sulat, no? Ganyan talaga pag nagmamadali. So the arctan of 0.1 is 5.71 degrees. So meron tayong beta, ang wala pa lang tayo is lambda. So we all know that the lambda is the arctan L divided by pi dm. So meron na ba tayong lahat niyan? So we all know that yan. Naglalag na, no? So sobrang dami yung sinusulat natin. So the arctan of what is your lead? Your lead is equal to pitch because it is a single threaded as stated in the problem. 6 divided by pi times dm. Of course, your dm you have here 29.375. So lambda mo is 6 divided by pi times 29.375 sa ilalim, arctangent. So this will become 3.72 degrees. So yun, meron ka ng beta, meron ka ng lambda. So ayun, meron tayong W, meron tayong dm divided 2. So our torque will become, W mo is 57,000 times dm mo 29.375 divide 2 kasi WDM divided by 2 times tangent, yung sum ng beta and lambda. Beta is 5.71, your lambda is 3.72. We have this answer in Newton mm, 139,045.89 Newton mm. So how about TC? So TC is just a direct sub WDC divided 2 times FC. So TC is equal to 57,000 times DC. Nasa yung DC natin, 45 mm divided 2 times the FC, which is this. So W, 57,000 times DC, 45 mm times FC, 0.1 divided 2. And we have this 128,000 and 250 Newton mm. So ayun guys, pwede nating makuha yung total power input kasi meron tayong T total which is equivalent to TR plus TC. And ayun, sa sobrang dami ng susulat natin, kailangan nating magbura. So ano-ano ang kailangan nating burahin? So pwede natin burahin itong taas. No? Kasi hindi ko siya pwedeng burahin lahat kasi may mahalaga pa tayong detalye. So lahat man tayo may experience magbura ng board, pero pag nagbura ka ng sulat dito no sa setup na to, medyo mahirap din pala. Pero syempre mas malinis to. So ayan. So our power input will be, so malapit na tayong matapos. Is total torque TR plus TC. So you have the TR here, 139,045.89 plus TC. You have the 128,250 here. Multiply daw natin ng, of course, ito, Newton mm na yan. Multiply natin ng 45 RPM divided by 9.549. So, medyo ano rin pala magsulat dito, no? Pero okay lang. So, that will give you a power input in kilowatts. So, ayan, sana tama ang ating mga values. 45.89 plus 128,250 times 45 RPM divided by 9.549 is to 6. So, yun. Meron tayong 1.26 horsepower. So, ayan, medyo naglalag na yung ating ano, no? So, 1.26 kilowatts, rather, kilowatts. 1.26 kilowatts. Yeah, all right. Meron na tayong power input. And determine naman daw the efficiencies. So I'm going to erase again some of the details that is not important anymore. So yan. 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 Ito siguro. So ito rin siguro na. So ayan. Okay, so yun. Hindi ka naman na-inep, no? And ayan, so efficiencies tayo. So efficiencies of screw alone, we all know that that's the ratio of the TO divided by TR. So ang alam na, wala tayong TO kanina pero meron na tayong TR. So asan TR natin? TR, yan. So you'll know that the TO is just WDM divided to tangent lambda only. Kasi nga, siniro mo na si beta dyan eh. Kasi yan yung torque required mo, no? Para ma-neglect mo yung thread friction effect. So that will become, W mo is 57,000 times, ano yung DM mo kanina? 29.375 divide 2 times tangent lambda. What is your lambda? 3.72. That will give you 54,000. So liliit talaga kasi nawalan ka ng beta doon. Okay? Ba? Times Yeah. So lumiit siya kasi nga nawalan ka ng beta. So your efficiency will become TO ER. So this will become 54,431.95 divided by TR mo is 139,045.89. Parehong Newton mm cancel times 100%. And you have the efficiency of the screw alone, 54,431.95 divided by 139,045.89. And you have the 39%. So tignan natin, kapag ginawa natin yung efficiency ng screw and the collar, kailangan mas malaki si efficiency of screw alone. Kasi lumaki yung denominator mo sa EK. That will become TO divided by total torque. So your TO is 54,431.95. And your total torque is pagplusin ko na yung nandito. No, kaya hindi ko rin binura ito kasi yan yung total torque 139,045.89 plus 128, 250, 267,000. 295.89. So that will give you 20.36%. So ayan, dalawang efficiency, compare mo, and that will speak that EK is less than E. Alright. Ayun, so ayan, sa isang problem, marami tayong pinagdaanan bago tayo makarating sa ating mga sagot, pero it helps us improve, no, our unit analysis, our awareness kung ano yung mga hindi given, ano yung mga nawawala. So thank you for listening, guys. So I will update more videos about certain topics on mechanical engineering, of course on engineering sciences also. So salamat sa pakikinig. Again, I'm Engineer Jason Bautista and welcome to the ride. Bye-bye and thank you.